All right. So now let us look at exercise 4. Again, exercise 4 is about applications of sound wave. So applications of sound wave, if you remember, we have three type of application in our syllabus. Okay, of course, in reality, there's more than three. But in our syllabus, we're just going to look at three. The first one is the string. Okay, when you plug the strings, you're actually creating the wave along the string. So what happened? So when the string they reach both end, both fixed end, the wave will be reflected, and therefore it forms a stationary wave in between two fixed end. So when it comes to string, the things that you have to remember now, when it comes to this subtopic, okay, you need to know how to sketch the diagram, because quite often questions will ask you to sketch the notes and anti-notes diagram, right? So when it comes to strings, the things that you have to know is that now you have two notes on both end, okay, two notes on both fixed end. So that is the things that you need to know. And then the second thing would be, okay, the second applications would be open end pipe. Okay, open end pipe or open end air column. Okay, sometimes questions they will use the terms air column. So air column actually is the type of a pipe. So it looks like this. Okay, it looks like this. Open at both ends. So if you have an open end air column, then what is going to happen? You will have anti nodes at both ends. Okay, anti node at both ends. And then the last one, if you have a closed end air column, okay, closed end air column. Now, closed end air column, it doesn't mean that it is closed at both end. Okay, it just closed at one end. So sometimes questions will tell you the pipe is closed at one end. Sometimes the question will just tell you now you have a closed end pipe. Okay, or now you have a pipe with one end open. Also can. All right, it means it is a closed end air columns examples. So when it comes to closed end air column, okay, the closed end side, the closed end part is a node, and then the open end is antinode. Now the reasons why you have antinode at the open end, that is because it has a less pressure here, and then in the closed end it has a higher pressure. Therefore, okay, you have a node there. Okay, all particles they vibrate, they focus at just one point. Then the one more things that you need to know about the closed end air column is that it only has an odd harmonic. Okay, odd harmonic. So odd harmonic means that it doesn't have a numbers, okay, harmonic, and it doesn't have a 2, 4, 6 those value, okay, the even number. It has only odd number 1, 3, 5, 7, and so on. Whereas for two examples above, okay, for the strings and the open end air column, both of them their end start from 1. Okay, n equals to 1, 2, 3, 4, 5, and so on. Where n equals to 1, it is the value for fundamental frequency. Okay, fundamental frequency. And then n equals to 2, 3, 4, 5, so on. That is your overtone. Okay, first overtone, second overtone, third overtone, and so on. So your fundamental frequency, which is the first harmonic, and then second harmonic, this is your first overtone. Okay, if you remember, overtone, it is a frequency above the fundamental frequency. So you need to know the difference, okay, the difference between these two things. All right, overtone, harmonic, they are not the same. They are different. Okay, they are different. Okay, now let us go back to the questions. So questions 1, a stretched wire. So wire is an example of a string, applications of string. Of length 80 cm, you have L, and then the mass 12 gram, vibrate transversely. A wave travels along the wires at a speed of 220 meter per second. So this is the V along the strings, right? So three antinodes can be found in the stationary waveform in between two fixed end of wire. So when it comes to this example, sometimes students, you don't know how to sketch it, right? So what you have to know, okay, is the things that I told you just now. You look at the examples, the summary here. When you have a string, you must have note on both ends. Okay, you must have a note on both ends. So how are you going to sketch the diagram for questions A? Now, if you're truly clueless in an exam, what I will suggest you to do, you sketch the shape for stationary wave first. Okay, tak kisah. Okay, you just sketch dulu. So if you truly have no idea on how to do it, kamu sketch diagram biasa dulu. Okay, untuk stationary wave. So you just sketch the diagram first without answering the questions. Okay, maybe you can sketch it on your questions paper, on a draft paper, and so on. And now, what are you going to do? If you know that when it comes to string, you should have knots on both ends, then you can take here as a starting point. Okay, so this is the knot. So you have the knots here. And according to the questions, you need 3 antinodes in between 2 knots. All right, you need 3 antinodes in between 2 knots. So let's see. Now, this is your knot. The first antinode is right here. And then the second antinode is here. And the third antinode is here. Now that I have 3 antinodes, I need to find the ending for my wave. Okay, so what should I do now? I need to identify the closest node after the third antinode. Okay, so sekarang macam mana saya nak sketch diagram? Saya ada 3 antinode punya posisi. So apa yang saya nak buat? Saya nak cari nodes yang terdekat dengan antinode ketiga ini. Okay, dengan antinode ketiga ini. So the closest node to this antinode is here, right here. So this is the node, which means, okay, my answer will be this part. I'm going to crop this part out. Okay, I'm going to crop it out and take it as my answer. Why? Because now I have nodes on both ends and 3 antinodes in between them. So this is the answer for questions A. Okay, so after you draw this draft on the draft paper, this is a diagram on the draft paper or questions, then you may crop this part out and put it in your answer paper. So you have a 2 fixed end. Okay, so this is a first one, second one, third one. And then here, okay, so now this is a fixed end. So this is the answer, okay, according to the part that I crop out. Oh no, I draw it in salah. Okay, so I'm going to draw 2 fixed end first to make it easy. 2 fixed end. I'm going to move this part out. So the green color part looks like this. Okay, I crop it out. And then the blue color part. Okay, so this is the answer for my questions 8. With a 2 nodes, okay, at both fixed end, and then 3 antinodes in between them. And since you are given the length, you need to label the length in the diagram as well. So L equals to 80 cm. Or you can write it as 0.8 meter also can. So that is how you sketch it in your exam. Okay, that is how you sketch the diagram in an exam. So yeah, that's it. Okay, 2 fixed end with nodes on both sides. All right, 2 fixed end. You have a node at the both end because now you are dealing with strings. So the main difference between strings, open-end air column, and a closed-end air column is the diagram. Open-end, you have antinode on both ends. String, you have nodes on both ends. And when it comes to closed-end air column, you have 1 node and 1 antinode. So that is how we use to identify, okay, to identify the diagram belongs to which types of applications. And questions B. Determine the wavelength of progressive wave which move along the wire. So now you want the wavelength, which is lambda. Now you look at the questions again. According to the questions, you have a V. And this V is the wave speed. Okay, if you read the whole sentence, now you read the whole sentence right here, it tells you wave travel along the wire at a speed of 220. So this indicates that the 220 given is the wave speed. So when it comes to wave speed, we have just one equation, which is V equals to F lambda. Okay, this is the general equations. Of course, you could have any other equations depending on the medium. But when it comes to general equation, we have V equals to F lambda. So V equals to F lambda, and the questions want us to calculate the wavelength. So, okay, now do we have the frequency? That would be the questions. No, right? But then again, if you look at the diagram now, since we're talking about lambda and we don't have frequency, is there any other method that we can use to calculate the wavelength? There's another thing that we can do by looking at the diagram. So since this equation, we cannot solve it. we cannot identify, we cannot determine the frequency yet. And it is being asked in the following question. That means this is not a good choice. Okay, this is not a good choice for questions 1. So try to think, do we have any other ways to determine the value of a wavelength? Yes, you do. Look at the diagram. If you look at this diagram, the diagram in a questions 1. In the diagram in questions 1, in between two fixed end, you have L equals to 80 cm, or we say equals to 0.8 meter. And if you look at the wave, now you look at the wave. Let's say this is the equilibrium line. Okay, this is your x-axis. If you look at this diagram, now what you have right here is, from here to here, this is 1 lambda. And then from here to here, this is 1 over 2 lambda. Altogether, you have 3 over 2 lambda in between two nodes, which tell us that L at the same time is equals to 3 over 2 lambda, according to our diagram in questions A. So now that you can combine these two statements, these two information, then solve it and determine the values of lambda. So 3 over 2 lambda is equals to 0.8 meter. Rearrange the equations, you'll be able to obtain 0.533 meter. So you have another method that can be used to determine the values of lambda other than V equals to F lambda. Okay, so now that I have lambda, I can then proceed to questions number 2. Determines the frequency of the vibrations of the wire. So V equals to F lambda, given V equals to 220 equals to F lambda obtained is 0.533. So rearrange the equations, I then obtain F equals to 413 hertz. Okay, F equals to 413 hertz. And then the last question asks us to determine the tensions in the wire. Now, if you look at this diagram, you cannot determine the tensions by using the things that you learned in chapter 4. Okay, because you don't have the free body diagram, you don't know what happens exactly. But what you do know is that you plug the string. Okay, you plug the strings and then you exert the tensions on the string. So what happens right here, since you're looking at wave, okay, wave speed. So speed of wave inside wire can also be determined by V equals to square root T over mu. Now try to think, can we use these equations to solve this question? Do we have the values of a V? Yes, we do. It is 220. Okay, this equation is for the wave speed in string. Okay, the medium must be string. So you cannot use it for air column, right? Remember, this equation is only valid for string. And then T is the things that we want to determine. Now, how about mu? Mu is the mass per unit length. So you can use it. You can use M divided by L to determine the values for mu. Okay, so mu is equals to M over L. So given M is 12 grams just now, so we have 12 times 10 to the power of negative 3 divided by 0.08. So make sure everything is in SI unit, because now you want to calculate force and then your velocity is in SI unit. Therefore, your mu should be in SI unit as well. So it is equals to 0.015. Mass is kg. Length is meter. Okay, kgm negative 1. So that is the value for mu. Okay, that is the values of mu. So now that you have mu and then you have V, you can then proceed to these equations. So V equals to 220. So 220 equals to T divided by 0.015. Rearrange the equation. Tension is then equals to 726 Newton. So that is how you solve it. Everything starts from a diagram. Okay, everything starts from a diagram. So if you can sketch the diagram, okay, if you're able to sketch the diagram, then you should be able to solve this question. Right? So this is the answer for questions 1. So I will give you some time to write it down, including the summary, okay, as part of a revision. So make sure you know the important things, the crucial part, the crucial things in 10.4. Okay, 10.4 is the hardest subtopic in chapter 10. So if you can understand 10.4, then it means you understand standing wave, right? So I give you 5 minutes to write it now, including the summary. Okay. Okay, if you have any question, if there's anything you don't understand, make sure to ask. Okay, if you understand, then you may try the following questions because you still need to sketch a diagram. Okay, questions 2. So questions 2, now you have a tube of a 60 cm long, and now if you look at the question, this is what I told you just now. Sometimes questions will just mention close at one end. Okay, a tube closed at one end. This is a closed end air column. So resonance occurs and the vibrating air column in the tube produce sound of a frequency 992 hertz. Okay, 992 hertz. So you have a frequency that is equivalent to 992 hertz, but you don't know this frequency will belongs to which harmonic yet. Okay, so the third overtone mode is found. Okay, now it tells you the third overtone mode is found in the air column. Third overtone is which harmonic? So if you remember, fundamental frequency, okay, fundamental frequency, we say n is equals to 1. First overtone, now if you recall the things that I've told you before, when it comes to closed-end air column, which is a closed-end pipe, we have only odd number harmonic, which means if you have a first overtone, when it comes to first overtone, n is equals to 3, but not 2. Okay, n is equals to 3, not 2. So second overtone, we have n equals to 5. And the third overtone, we have n equals to 7. So this is the 7 harmonics example. Okay, we have a 7 harmonics right here. So questions A, sketch and labels the wavefronts of the air column. So how are we going to sketch the diagram? Okay. So now let's see. Okay, let's see. Let us begin with a general shape as usual. Okay, so this is the wave, stationary wave. I'm just going to sketch it. Okay, I don't know where am I going to start yet. All right, I'm just going to sketch a general or stationary wave shapes. Okay, now if you look at the closed-end air column, if you remember the characteristics of the wave is that the open end must be antinode and the closed end should be node. So let us begin with nodes. Okay, let us begin with a node, and then I'm going to write down to label the antinode first. So A, these are all my antinode. Okay, so how many antinodes should I include in my diagram? Okay, how many antinodes should I include in my diagram? Actually, it's very simple. Okay, actually, it's very simple. You look at the statement above. Okay, here, right here, I have 4 types of resonant frequency, which means antinode happens for 4 times. Okay, it occurs for 4 times. It repeats 4 times. So I need to have 4 antinodes in my diagram. Okay, I need to have 4 antinodes because right here I have 4 resonant frequency. Third overtone means the resonant frequency, it can happen at 4 times. All right. So I start from nodes. This is my first antinode, my second antinode, my third antinode, and my fourth antinode. Okay, and then according to the characteristics of the closed-end air column, the wave should end as an antinode, which means here would be the cutting line. Okay, here would be the ending for my wave. So I'm going to crop this part out and then put it in my closed-end pipe here. Okay, so this is my closed-end pipe. So I'm going to sketch a diagram like the one in on the right-hand side. So I have a shape like this, one wave, and then antinode, and it ends right here. Okay, it ends right here. So it should touch. Okay, it should touch up. 1, 2, 3, 4. Okay, so that is the diagram. So I'm going to sketch the wave in the opposite direction. Okay, in the opposite direction. So right now what I have here is I start from a node and then 1 antinode, 2 antinode, 3 antinode, 4 antinode. Fundamental frequency, first overtone, second overtone, third overtone. So that is the right answer. Okay, that is the right answer for questions A. So according to the questions, now the length of this closed-end pipe is 60 cm. Okay, 60 cm. So we have L equals to 60 cm. So that's it. Okay, and one more thing that students will ask is what does it mean by ignore the end correction? So end correction now, usually, okay, if you look at my sketching, okay, the initial sketching, when I sketched it just now, Okay, there's some there's some part, okay, there's some part without the wave. My wave didn't touch here, okay, it ends at this point. The wave ends at this point. So the additional part without the wave, without touching, this is the end correction. So in an actual situations, actually you have an equation for you to calculate the end correction. But that one is no longer in our syllabus. Therefore, questions ask you to ignore end correction. We assume we have a nice perfect graph, okay, a perfect wave that ends sharp at the edge of the pipe. Okay, kalau tidak, di reality sebenarnya dia ada sikit lagi ruang yang tak ada wave. Okay, dia mungkin habis sebelum dia touching the edge of the pipe, hujung-hujung pipe. So di sini kalau dia ada tempat yang ada ruang kosong, dan kita kena kira nilai end correction. Okay, kita kena kira nilai end correction. But now because question asks you to ignore it, so we assume we have a perfect standing wave in our closed end pipe. So that is the answer for questions A, and that is how you sketch it. Okay, third overtone. Third overtone, including fundamental frequency, means you need to have 4 antinodes. All right, you need to have 4 antinodes in your diagram. So questions B, calculate the speed of sound in the air. So how do you calculate the speed of sound? So speed of sound, V is equals to, now, when it comes to speed of sound in the air, if the medium is air, then we know the value is a constant value, which is 340. My questions want you to calculate. So you cannot straight away write down V equals to 340. What you can do is just calculate it by using F lambda. Okay, you can only calculate it by using F lambda because, well, even though you know it is a constant value, but you cannot assume you know it. Okay, you cannot say you know it. So you need to pretend you don't know the value. Okay, you need to pretend you don't know the value, and then you solve it, you calculate it. So if you can get 340, then that means you got the right answer. But now, if you look at the question again, the values that you have is just a frequency. You only have the value for frequency, which is 992 hertz, but you don't have L. You don't have lambda. But what you do have is the L. Okay, and according to my diagram, okay, so this is the equilibrium position. So according to my diagram, from here to here is a 1 lambda. Okay, and then from here to here is, okay, this is lambda. Here is not one complete lambda. What you have right here is just 3/4 lambda. So altogether, it's a 7/4 lambda. Okay, therefore we can say L equals to 0.6 meter, and at the same time, L is equals to 7/4 lambda. Okay, so combining these two pieces of information, we obtain, okay, 7/4 lambda equals to 0.6. Lambda is then equals to 0.343 meter. So that is the values of lambda. So now that I have a frequency from the questions, I have a lambda from here. Therefore, I can calculate the speed. So V equals to 992 times 0.343, and then it is equals to 340 meter per second. So that is how you solve it. So again, this question, if you don't know how to sketch the diagram, then you wouldn't be able to solve it. Okay, because you need the information, you need the relationship between L and lambda from your diagram. That's why I keep telling you guys, diagram is very, 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 very important in chapter 10, in a 10.4. Okay, in 10.4. Okay, now let's see. Questions 2 asks you to calculate the fundamental frequency. Okay, so can you calculate fundamental frequency? Yeah, well, of course you can. So a fundamental frequency, okay, what we do know is a Fn equals to NF1. Okay, F1 is your fundamental frequency. So right now we have the 7th harmonic. So F7 is equals to 7 times F1. So F7, the value given is 992 hertz equals to 7 F1. Therefore, fundamental frequency is equals to 142 hertz. Okay, so this is the shortcut. Okay, this is the shortcut. Another method, okay, alternative method, So if in case you couldn't remember this relationship, then you can use alternative method by using the general equation for closed end air column, which is Fn equals to Nv over 4L. So fundamental frequency, at a fundamental frequency, N is equals to 1. Okay, this is for fundamental frequency. So fundamental frequency, N is equals to 1. Therefore, F1 is equals to 1 times 340 divided by 4 times 0.6. So eventually you should obtain 142 hertz as well. Okay, you should obtain 142 hertz. So you have two methods that can be used to solve it. Okay, so it's up to you which one you want to use. So again, I give you 5 minutes to write it down. Okay, after that, the remaining two questions actually is just a very simple. Okay, so yang penting dua soalan yang pertama ini sebab anda belajar macam mana nak lukis. Okay, if you are given the numbers of an antinote or if you are given a questions in terms of a harmonic or overtone. Okay, so dah belajar cara untuk sketch. Sekarang saya bagi anda 5 minit untuk catat diagram untuk fahamkan semua ini. So if you have any questions, you may ask. Okay, if you have any questions, you may ask. Okay, let's proceed to the next question. Okay, next question. Okay, this question, you need two equations. Okay, you need two equations. You are given the same air column, a 2-meter air column. Okay, a 2-meter air column is open at both ends. So open at both ends. This is an open end air column, an open end pipe right now. The frequency of a certain harmonic is a 410 hertz, and the frequency of the next higher harmonic is 492 hertz. Determine the speed. Okay, determine the speed of the sound in the air column. Again, the end corrections may be neglected. So what am I going to do right now is I want to see for frequency. Okay, the frequency of a certain harmonic is 410 hertz. So let's say Fn, because I don't know. Okay, I just know it's a certain frequency. I don't know it belongs to which harmonic. So Fn equals to 410 hertz. Okay, and then what I have right now is the next higher frequency. Next higher, well, I'm going to write Fn plus 1. Okay, just plus 1 because it's open end air column. If it is closed end air column, then it will be n plus 2. All right, so Fn equals to 492 hertz. Okay, 492 hertz. So this is the information that I have. And then how am I going to link them together? Now, if you want to link them together, obviously you need equations. And the equations that can be used in an open-end air column, open-end air pipe, is Fn equals to NV over 2L. Okay, NV over 2L. So what am I going to do right now? I'm going to form two equations. So for the first one, okay, for first one, 410 hertz. So Fn, which is a 410, equals to NV over 2. Now, L given is 2 meter over 2. So this is my first equation. The second equation, okay, the second equation is 492 hertz equals to N plus 1 times V divided by 2 times 2. This is the second equation. Okay, this is the second equation. So now I can solve simultaneously. Okay, I can use simultaneous equations to solve both equations. So the easiest way would be determines the numbers of harmonic first. Okay, to determine the n first. Okay, so let's see how am I going to solve it. Rearrange the equations, then I will obtain 410 times 4. Okay, 410 times 4 divided by n equals to v. So on the other side, for the second equation, 492 times 4 divided by n plus 1 equals to v. So I can use simultaneous equations to solve it. So if I solve it, okay, 410 times 4, I equal the two equations. 492 times 4 divided by n plus 1, and I will obtain n equals to 5. Okay, n is equals to 5. So now that I have n, what I can do, I plug it back into the equations. Okay, equations 1 most probably. So I put it in equations 1, I will then obtain, okay, if I put it back into equations 1, I have 410 equals to 5v divided by 4. So v is equals to 328 m as negative 1. Okay, 328 m as negative 1. So that is the answer for questions 3. Questions 3. Okay, questions 3. You're right. Velocity is equals to 328. Let's see. So you try to calculate, yeah, see whether the value is correct or not. So saya cuma agak-agak kira saja, kamu sendiri kira semula, tengok betul tak nilai dia. So this is just a very simple question. What you need is just two equations because you are given two different scenario from the same pipe, same air column. So when it comes from the same air column, okay, we have the same length, and also same frequency because you're using the same medium, you're using the same air column, same pipe. So the air, the speed of wave, the speed of sound, they will be traveling at the same speed. Okay. So next, last questions in a 10.4. So after that, we will discuss the second questions in the Doppler effect. Okay, because we still got one more questions that we couldn't finish on Wednesday. So what is the frequency of the sound emitted by an open-end organ pipe? So open-end organ pipe, again, is an open-end air column, 7 meter long when the sounding is a fundamental frequency. So we are given L, and then you are given the V, and a question is asking for the frequency, okay, the frequency, okay, fundamental frequency. So fundamental frequency, we know N is equals to 1. And then for open-end pipe, the equation is Fn equals to Nv over 2L. So F1 is equals to 1 times the V340 divided by 2, 1.7. Therefore, it is equals to 100 hertz. So it's very simple. The crucial part is you know the numbers of harmonic for fundamental frequency is always equal to 1. Okay, it's always equals to 1. So F1 equals to 100 hertz. Right, so 1 minute for you to write it down. Then we will go to a Doppler effects question. All right, last question. Okay, now this question is a typical question that shows you an observer. It could be a living things or it could be a non-living things. Okay, so now let's see. What is happening in this question is that figure shows O is a stationary observer and source as it moved away from the observer and it moved towards the wall with a speed of 40 meter per second. The frequency of the source is 1000 hertz and given the speed of sound. So you need to remember when it comes to Doppler effect, what we should have is 5 different variables. Observed frequency, the frequency observed by the observer, and then source, frequency of the source. Now in this question, Fs is given as a 1000, okay, 1000 hertz. And then VO, observer frequency, velocity, okay, how fast does the observer move? Right now, I still don't have the information yet, okay, because I don't know which one is my observer. Questions hasn't helped me. Even though it mentions observer O, but if you look at the question, it is asking about wall. What happens to the wall? All right, so VO, I'm going to leave it blank right now. I'm going to assume I don't know what is the value yet. And then Vs, given Vs, the speed of source, okay, not the speed of sound, the speed of source. So Vs is equals to 40 meter per second, okay, 40 meter per second. And then the last one is a speed of sound, which is just V without subscript. So given 340 meter per second. So the information that I have right now is the information about the source. Okay, I don't have the information for the observer yet because I don't know who is my observer. Now, questions 8. The wavelength in front and behind of the source if there's no wall. Aha. So now it assumes this is your source In front of the source and behind the source, there's nothing. You're just looking at the source. And you remember, if you remember, sound is emits out in all direction, okay, which means both direction will have the wave. So now it asks you to calculate the wavelength. In order to calculate the wavelength, the things that you need is the frequency. All right, you need frequency because V is equals to F lambda. If you want to have the frequency, if you want to have the lambda, the wavelength, then you need frequency in this case. So how are we going to calculate the frequency? So you can assume, okay, this is an imaginary observer. So I'm going to call it O front. Okay, so this is an imaginary point. So it doesn't mean that there must be a living thing in order for you to calculate the observed frequency. It could be any point. So this is another imaginary observer. So front and back. Okay, front and back. So I have two. Okay, front and behind. Okay, in front and behind. Better use the term behind. Okay. So now I have two imaginary observer. Okay, one is in front, one is behind. So how am I going to solve it? If you look at the question, now it tells you this sound, the source is moving towards the wall, which is moving to the left-hand side. So this is the direction of your Vs. Okay, this is the directions of your Vs. Then how about the directions of V? For observer in front of the source, okay, for observer in front of the source, the direction of V is going to the left. For observer behind the source, the directions of V is going to the right. Okay, so you need to know the directions of V in order to determine, to find out, to calculate, okay, to calculate the frequency, the observed frequency. So kamu kena tahu directions V dulu. Why? Why? Because it will affect our value of, it will affect our sign convention. If Vs and V, okay, they are in the same direction. Okay, if they are in the same direction, then we use negative sign in our equation. If Vs and V, they are in the opposite direction, then we use positive sign. Okay, then we use positive sign. So this imaginary observer, we are going to assume it is not moving. Therefore, we say VO is equals to 0 and S negative 1. So from here, we should be able to determine the frequency. General equations given, FO is equals to V plus minus VO over V plus minus VS times Fs. So now VO is equals to 0. So FO is equals to V over V plus minus Vs Fs. So for the observer at the front, okay, for the front of the source, you use negative sign. For the one behind, you use negative sign. After you obtain frequency, you then calculate it by using V equals to F lambda. Lambda equals to V over F. Okay, so kamu sendiri kira. I show you the method and then you calculate it by yourself, right? And then questions B, the apparent frequency heard by the observer, okay, directly from the source. So observer is standing behind, therefore you have the answer already, okay, you have the answer already. So your observer actually is equals to, okay, your apparent frequency, F observer, you're going to use the one at behind. So basically, you just rewrite it, okay? You just rewrite the observer at the behind. So this is your source, and this is your observer. Okay, source is moving to the left, and then the sound is going to the right. Sound always traveling from source towards the observer. And then my VO, according to the question, VO is not moving. So VO is equal to 0 meter per second. So that is how you solve questions B. Basically, you just rewrite the thing that you have already calculated in questions A. Okay, now this is the questions that I want to discuss with you. The apparent frequency heard by the observer caused by the reflections on the wall. So what happens right here? Now the wall is located at the front of the source. This is a wall. Okay, and then this is a source. So source is emitting sound. and source is going towards the wall. So this is your Vs, and then your V is also traveling towards the wall. So basically, this is an example of questions that involve the front of the object. So all front. Okay, now your wall is acting as the observer in this question. Okay, wall is acting as observer. So wall observe. Okay, wall observe the frequency. So it receives a frequency, and then frequency is being reflected. So case number two, now this is the wall. Okay, so after the sound being reflected, your wall is now acting as the source. So initially, this is the observer. Okay, and then after that, it is acting as the source that emits frequency. And now this is the observer, the human. Okay, the human observer according to the question. This is your O. And now both of them, since both wall and the observer, they are not moving, what happened after the source is the sound being reflected? Your Vs is equals to 0. Your Vo is also equals to 0. So by applying the general equation, Fo equals to V plus minus Vo over V plus minus Vs Fs. Since both of them, they are equals to 0, Fo equals to V over V Fs, which is equals to 1. Therefore, F observer is actually equals to F source. If you have both stationary observer and stationary source, then this is what going to happen. Okay, this is going to happen. Okay, now it's 11 a.m. Group A, if I'm not mistaken. You may leave the class first, okay, because you have another class. All right. So you just write it down. Once you write it down, then that's all. Okay, that marks the end for today's class. So I just give you an idea. You solve it by yourself. If you have any questions, you may ask in the group. Okay, if you have any questions, you may ask in the group. So you may leave the class now.